Imagine receiving a signal from the farthest reaches of space, one that points to a planet unlike any we've ever seen. A place that defies everything we thought we knew. A planet that might offer a new home, or a deadly trap. What if the very foundations of our understanding of the universe were about to be shattered? The James Webb Space Telescope has just unearthed revelations so extraordinary that they could rewrite the rules of life itself. But is Proxima b, a planet orbiting the nearest star to our solar system, truly a potential new Earth? Or could it hide dangers that make it uninhabitable? I'm Bob, and you're watching Space Theory, where the mysteries of the universe come alive. Let's take a step back. Proxima b orbits Proxima Centauri, the closest star to our solar system, just 4.2 light-years away. That's practically next door in cosmic terms. Since its discovery in 2013, Proxima b has been one of the most talked about exoplanets, sparking imaginations and speculation. It's rocky, sits in the so-called habitable zone, and is roughly the size of Earth. Sounds promising, right? But as we delve deeper, things take a darker turn. While Proxima b orbits within a distance from its star where liquid water could exist, it does so at an incredibly close range, just 7.3 million kilometers away from Proxima Centauri. For perspective, that's less than 5% of the distance between Earth and our Sun. At this proximity, Proxima b completes a full orbit in just 11 Earth days. But that's not the weird part. The star it's orbiting isn't like our Sun at all. Proxima Centauri is a red dwarf, a type of star known for its unpredictable and violent temper. These stars regularly unleash solar flares, a sudden eruption of energy that can blast nearby planets with deadly radiation. Think of it like living next to a fire-breathing dragon that could lash out at any moment. Proxima b isn't just in a dangerous neighborhood. It's practically sitting in the dragon's lair. Here's where the James Webb Space Telescope, JWST, steps in. With its infrared eyes, it has taken the most detailed look at Proxima b to date, and the results are jaw-dropping. One of the most significant revelations? Proxima b might be tidally locked asterisk to its star. This means that one side of the planet always faces Proxima Centauri, while the other is permanently shrouded in darkness. Imagine standing on a world where the sun never rises, or never sets. The day side of the planet would be exposed to constant, scorching radiation, likely turning the surface into a barren, desert-like wasteland. Meanwhile, the night side would be a frozen hellscape, plunged into perpetual darkness with temperatures colder than anything we've ever experienced on Earth. But in between these two extremes lies a narrow strip of land known as the Twilight Zone. This thin, transitional area might be the most temperate part of the planet, where the fiery heat from the day side meets the frozen night side, creating a zone where life, just maybe, could survive. Could this be Proxima b's oasis? A sliver of habitability in an otherwise hostile world? It sounds promising, right? A habitable zone where water might exist, where life could find refuge. But the more we learn, the more dangerous Proxima b seems. For one, the planet is about 30% larger than Earth, which means it has a significantly stronger gravitational pull. If you were to visit, you'd feel the weight of that extra gravity dragging you down. But that's just the beginning. The biggest threat comes from Proxima Centauri itself. Red dwarfs like Proxima Centauri are known for their violent solar flares, and the JWST has confirmed that this star is far more volatile than we initially thought. In April 2021, a solar flare erupted from Proxima Centauri that was 100 times more powerful than any flare ever recorded from our Sun. Imagine the impact that would have on a planet orbiting so close to its star. The radiation from such an event could strip away Proxima b's atmosphere entirely, leaving it exposed to the cold, unforgiving vacuum of space. Without an atmosphere, any hope for life as we know it would be dashed. Water would evaporate, and the surface would be bombarded by deadly ultraviolet and X-ray radiation. And yet, even with these catastrophic dangers looming, scientists are still holding on to the possibility that life might find a way to survive in this extreme environment. Could life evolve to withstand such brutality? But wait, there's another twist in the story. Even though the surface of Proxima b may be inhospitable, the JWST has raised the possibility of subsurface oceans, hidden beneath a layer of ice, similar to the conditions found on moons like Europa and Enceladus in our own solar system. These oceans could be heated by Proxima B's core or by the gravitational pull of its star, creating a liquid environment beneath the surface. If that's the case, these hidden oceans could be prime real estate for alien life. Tucked away from the harsh radiation above, imagine life thriving in these dark, hidden depths, evolving in ways we can't even begin to comprehend. Could Proxima B be home to strange, resilient creatures adapted to life in a place where the surface is a war zone, but the deep oceans remain untouched? But it's not just the radiation or the possibility of hidden oceans that makes Proxima B a planetary enigma. Proxima Centauri's magnetic field adds another layer of complexity. The magnetic storms generated by the interaction between the star and its planet could either shield Proxima B from some of the radiation or amplify the damage, causing catastrophic shifts in the planet's climate and surface conditions. These magnetic storms could trigger violent winds and atmospheric disturbances, making Proxima B's already hostile surface even more unpredictable. As more data from the JWST pours in, the questions about Proxima B keep piling up. Could life have evolved on Proxima B, surviving under these brutal conditions? If so, what would that life even look like? Would it resemble extremophiles on Earth, microorganisms that can survive in the most extreme environments, from the boiling heat of hydrothermal vents to the freezing cold of Antarctica? Or would it be something entirely alien? Life that has adapted to thrive in an environment unlike anything we've ever seen? The deeper we explore Proxima B, the more it forces us to confront the limits of life as we know it. This planet, just 4.2 light-years away, represents the closest test of our understanding of habitability and survival in the universe. But as intriguing as the idea of life on Proxima B is, the reality may be far less inviting. Imagine a world bathed in constant radiation, with temperatures that fluctuate between extremes of searing heat and bone-chilling cold. Proxima B exists in an environment that would be considered hostile, even deadly, to any form of life familiar to us. The powerful solar flares from Proxima Centauri could strip away the planet's atmosphere in the blink of an eye, leaving its surface exposed to the brutal vacuum of space. Without an atmosphere, the planet would be vulnerable to deadly cosmic radiation, and any water on the surface would evaporate into space, leaving behind a dry, desolate wasteland. Yet, despite this bleak outlook, scientists continue to search for signs of life. Why? Because, time and again, the universe has shown us that life is incredibly resilient, often finding a way to persist in even the harshest environments. On Earth, we've discovered life in the most extreme conditions. Organisms known as extremophiles thrive in environments we once thought were utterly uninhabitable. From the superheated waters of deep-sea hydrothermal vents to the icy deserts of Antarctica, life has demonstrated a remarkable ability to adapt. This raises a compelling question. Could something similar be happening on Proxima B? Could life exist in the shadows of the planet's twilight zone, that thin region between perpetual day and eternal night, where conditions might be just right for some form of survival? In this narrow band, temperatures could be more moderate, neither too hot nor too cold. If liquid water exists anywhere on the planet, this is where it might be found. Perhaps, deep within the crevices of Proxima B's rocky terrain, life could be hiding, eking out an existence away from the deadly radiation of its star. Life here wouldn't resemble anything we're familiar with. It would be an alien form of survival, evolved to cope with Proxima B's extreme conditions. These organisms might live underground, shielded from the constant bombardment of cosmic rays, or they could exist in the hypothesized subsurface oceans, similar to the hidden seas beneath the icy moons of Jupiter and Saturn. Could there be deep caverns filled with strange, alien microbes, thriving in a world where the surface is a cosmic battlefield? Or perhaps even more advanced life forms, shielded beneath thick layers of rock or ice, waiting for their moment to emerge? And what about the possibility of Proxima B harboring vast, hidden oceans below its surface? If subsurface oceans exist, heated by the planet's core or the gravitational pull of its star, they could provide a sanctuary for life, far removed from the destructive forces above. On Earth, deep below the surface, ecosystems thrive in total darkness, relying not on sunlight but on chemical processes for survival. Proxima B's hidden oceans could support similar ecosystems, with alien organisms evolving in isolation, surviving by feeding on the minerals in the water or the heat generated from the planet's core. As we consider these possibilities, we are forced to expand our definition of what it means for a planet to be habitable. Proxima B may not have the lush forests or vast oceans of Earth, but if life can survive in these extreme conditions, it could teach us more about the adaptability of life than any other discovery. Perhaps life, in some form, has managed to develop in ways that we can't yet imagine, thriving in places that appear desolate and dead to human eyes. But even as we speculate, the dangers remain real. The violent flares from Proxima Centauri could erase any nascent life in an instant, turning Proxima B into a barren wasteland. The planet's atmosphere, if it still exists, is likely a fragile shield, constantly eroded by radiation. And yet, if life can cling to existence on Proxima B, it would represent one of the greatest triumphs of survival in the universe, a testament to the resilience and tenacity of life, no matter where it takes root. Could Proxima B surprise us? Could we one day find evidence of alien life? Perhaps not as we imagine it, but life nonetheless, clinging to survival in the twilight shadows or beneath its icy crust. These are questions we cannot yet answer, but with the continued observations from the James Webb Space Telescope and other future missions, we may get closer to unraveling the mysteries of this distant world. Proxima B could become the proving ground for life's resilience, pushing the boundaries of where we believe life can exist and forcing us to rethink everything we thought we knew about the universe. As we probe deeper into the cosmos, Proxima B reminds us that the search for life is never straightforward. Even in the harshest environments, where survival seems impossible, the universe may still hold surprises. Life, as fragile as it seems, has a way of enduring in the most unexpected places. And Proxima B, with all its dangers and extremes, could be the key to unlocking the secrets of life beyond Earth. As the James Webb Space Telescope continues its observations, Proxima B remains one of the most tantalizing mysteries of our time. It may not be the next Earth we hoped for, but it is a reminder that the universe is full of surprises, some beautiful, some deadly. Proxima B is more than just a distant exoplanet. It's a cosmic riddle, a test of our understanding of life's resilience, and a warning that not all Earth-like planets are as inviting as they may seem. The story of Proxima B is still being written, and the next chapter may hold the answers to some of the biggest questions humanity has ever asked. What are the limits of life? And just how far will we go to find it?